Hello, in this video I will go over integrating powers of sines and cosine. This is not the same thing as integrating with trig substitution. If you want to go over integrating with trig substitution, that's another video. So in this section, you'll learn how to integrate, like I said, powers of sines, cosine, with the help of 6 basic trig functions, integration rules, and Pythagorean identities and half-angle identities. Yeah, this is not the same thing as trig substitution. It's actually a bit easier. Okay. So let's go over the 6 basic trig function rules. If you already know this, that's fine, but if you don't, go ahead and pause the video and write down the rules. Okay, so we're definitely going to use these. Okay, I'm going to move on. Uh, okay, then what we also need to know is the Pythagorean identities. So if you already know these, that's fine. If you have it on your notes, that's fine. But if you don't, go ahead and pause the video and copy because we're going to use these. Okay, and then the next one is the half angle identities. If you already have it, go ahead and skip through it. If you don't, pause and write down. Okay, so there's like when you're doing integration of the trig and power rules. So just remember, this is a very important note. When working with at least one odd number, power of either sine or cosine alone or any combination beginning. So okay, so what this means is if your sine or cosine is an odd power, what you want to do is factor out or peel off a single sine or a single cosine from the odd power, and then use your trig identities. Okay, so let me show you an example. Example 1, we have to take this integration of sin to the 5th x times cosine square x dx. Don't do integration by parts. Instead, what you want to do is use the rule. So do you see an odd power? Yes, I see an odd power at 5, and then 2 is even. So this is an odd power, and then this is even. So they say if you have an odd power, you want to factor out one sine or cosine. So let me do that. So I'm going to factor out one sine of x from sin fifth of x, because sin fifth of x is the same thing as sin of x raised to the fifth power. So you could take out one sine of x, and then you still have 4 more x's, or 4 more sins. And then I'm going to leave the cosine square x dx alone for right now because it isn't even. Okay. Then what you want to do is use your identities. So the identity, I'm going to use the Pythagorean identity to rewrite sin 4 of x, because here's one, I'll show you. One of our trig identity is this. One of your Pythagorean identity is this. Sine squared plus cosine squared equals 1. So what you want to do is maybe solve for, we don't see a sin 4, but we can definitely solve this sin square x by subtracting cosine square x from both sides, right? Okay, so sin square x is 1 minus cosine square of x. But there's a 4, so we gotta raise it to the second power. So what we can do is rewrite this as sin of x. And then we know that sin square of x is 1 minus cosine square x. You can replace this with 1 minus cosine square of x. But we still got to raise it to the second power because this is to the 4th, right? And then bring down the cosine square x dx. Let's see, what should I do? I'm gonna rearrange this for a bit. I'm gonna put the 1 minus cosine square x raised to the second power first. And then bring down the cosine square x. And then bring down the sin x dx. Okay, so this is where you're going to need to do, now we can do is use substitution. And we're going to use, what do you think u should be? You said cosine x, that's correct. So du, what's the derivative of cosine x? Is negative sin of x dx. The thing is, I have a positive sin x dx, so I have to get rid of this negative 1. To do so, I'm going to multiply both sides by negative 1, right? It's negative 1 du. This is positive sin of x dx. Okay, so we said that u is cosine, so you can rewrite this as 1 minus, and then we said that u is cosine, so this is going to be u squared. Raise it to the second, and then cosine square x is going to be u squared. And then what you could do is replace sin of x dx with negative 1 du. Okay, so then what I would do next is negative 1 is a constant, so I'm going to put it outside the integral. So I'm going to put it right here. Okay. And then what I'm going to do next is FOIL out this u squared. Or actually, no, I'm going to FOIL out the 1 minus u squared. I'm going to FOIL this part right here. So when you FOIL out 1 minus u squared, you get 1 minus 2u squared plus b squared, so that's like u to the 4th. And then bring down the u squared, du. Okay. Then what you would do next is, I guess you would FOIL out this u squared. So 1 times u squared is u squared. Negative 2u squared times u squared is negative 2u to the 4th. U fourth times u squared is positive u6. Du. Then what I would do is take the integration of each term by using your integration rule. So what's the integration of u squared? That is going to be 1/3 u to the 3. What is the integration of negative 2u fourth? That's negative 2u 5/5. What's the integration of u to the 6? It's 1/7 u to the 7th. And then we're still going to multiply everything by negative 1. So when I FOIL that out, I get negative 1/3 u to the 3. This would be positive 2/5 u to the 5. And then this would be negative 1/7 u to the 7. Let's see. And then lastly, just replace your u with cosine x, because that's what we said. So our final answer is going to be negative 1/3, and replace u with cosine x. So this would be cosine cube of x plus 2/5 cosine 5th to the x minus 1/7 cosine 7 of x plus c. And that's your final answer. Okay. So let me recap what I did. I realized that if you have an odd power, what you want to do is factor out or peel off a sign. That's what I did. And then I used my trig identities. And then I kind of boil it out. And then I did a u substitution. And then I just used my integration rule and plug in u for your u for cosine. Okay, so go ahead and absorb. I'm going to move on to example 2. So example 2, we have to take the integration of sin square x times cosine square x dx. So what is so significant about this? The only problem is if you look at the powers, this is a power 2 and this is also a power 2. They're both even powers, right? So it's not like we can peel off a sin or a cosine x. So you're going to have to use one of your identities. And the identity I will use is my half angle identity. Okay, so this should be on your on the lecture previous slide. So we said that sin square of x is 1 minus cosine of 2x over 2. And then cosine square of x is 1 plus cosine of 2x over 2. Okay, so what we're going to do is we're going to replace sin square of x with this 1 minus cosine 2x all over 2. Okay, times, and then I'm going to replace cosine square x with this 1 plus cosine 2x over 2. And then don't forget the dx. Okay, and then just simplify by multiplying and collecting like terms. So on the top, 1 minus cosine 2x times 1 plus cosine 2x. That is going to be 1 minus cosine square of 2x dx. And then on the bottom, 2 times 2 is 4. Okay. So this 4 is like the same thing as 1 over 4, right? So what you could do is factor out that constant. So this is 1 minus cosine square of 2x dx. Yes, 1 minus cosine squared to it. Now, you're gonna have to use another identity. So 1 is fine. Well, actually, did you know this is a 1, this is a constant, so what can you do with a constant? You can take that out. So let's do that. So I'm going to take out that 1. So if you have a 1 here and a 1/4, that's going to be 1/4. And then you have minus cosine square of 2x dx. And now you're going to use your identity. Did you know that cosine, this is also your half angle identity, cosine square of x is 1 plus cosine of 2x over 2, but cosine square of 2 theta or 2x is, in our case, it's going to be 1 plus cosine of 2 times 2x all over 2. So that is going to be 1 plus cosine of 4x all over 2. So this is going to be minus, and then cosine square x of 2x is 1 plus cosine of 4x all over 2. So if I FOIL out that minus, it would be minus 1 minus cosine of 4x all over 2. And then you still have this 1/4. Now, this 2 on the bottom is the same thing as 1/2, right? This 2 on the bottom is the same thing as 1/2. So that's what I'm going to do. I'm going to factor out that 1/2. So it's 1/2. And then you also have this 1/4. So now you're left with -1 minus cosine of 4x. Oops, don't forget the dx. That didn't disappear. Okay. So 1/2 and 1/4 is the same thing as 1/8. And this should be this should be positive. Okay, so now I have 1/8, and then I have to take the integration of -1 plus cosine of 4x, and then this is all dx. So what you can do is, there's two terms, so what you could do is take the integration of both of each one. So we know the integration of -1 is -x, right? What is the integration of cosine 4x dx? If you want, you can write it out as cosine of 4x dx. And then my u substitution would be 4x. So my du would be 4 dx. And then I have to get rid of this 4 by multiplying both sides by 1/4. This is 1/4 du. 4 times 1/4 is dx. So it's going to be cosine of u, and then you replace dx with 1/4 du. And then 1/4 is a constant, so you put that outside. And then the integration of cosine u is sine of u. And then you also have this -x. And then also remember we took out a 1/8, so we're going to multiply every term by 1/8. So your final answer is going to be -1/8 x. And then 1/8 times 1/4 is positive 1 over 32 sin of 4x, because our u is 4x, plus c. Okay, so that's our final answer, -1/8 x plus 1 over 32 sin of 4x plus c. Okay, that will end here. I'll stop here.